So in this chapter we're going to explore how we can make a ground floor from which the creature will inherit some motion vectors that will define. So the monster is going to sample velocity vectors from the surface while walking on it and apply those vectors to specific parts of the body. So we're going to make a regular grid. I'm going to make a little network box here like this and make a grid. This grid is going to be something like maybe 3 by 8 meters. So yeah, I'm just going to position it properly, and I'm going to add a bunch of segments. Hide the 3D world grid, and maybe even more segments. I think that's enough. So we're going to calculate some normals here. We're going to need those when we're going to build some forces inside Vellum. And let's check the normals. We have normals pointing up, and we're going to be making a attribute wrangle. We're going to define the properties of the ground. So the properties of the ground will be really simple, and we're going to define the friction here. These are parameters that are read by Vellum internally, and are used by default inside Vellum. So if you define such attributes on the ground surface, on the colliders, they're going to multiply between themselves, and this is going to be the final value of the friction is going to be the product of each of the colliding objects' friction and dynamic friction attributes. Also, we're going to add a point velocity, which is going to be a vector. I'm going to just set the value and put a -1 here. So as you can see, we have a vector pointing into the z direction, negative z direction, and yeah, we're not going to add any curl noise, nothing like this. Maybe later in the tutorial. And what I'm going to do is, yeah, maybe just in case, I'm going to make an attribute wrangle again, and set the velocity, or maybe set comp. Yeah, so set comp, it's a function that allows us to change the component of one vector to a specific value. So yeah, here we're going to define the velocity vector. We're going to set the value, and the vector component is going to be the second one, which is the y-axis. So I'm going to nullify or make the y-axis 0. If you want to check this, we can come close here, and if I add a y component to the velocity vector, as you can see, it's a diagonal vector, and when we activate the attribute wrangle, so the y-axis is going to be 0. So this is an expression a function that allows us to change that, so or set the value of that component to 0. So the vector, the value of the of our component, and the index of the component, which is 0, 1, 2, which means the 1 is the second component, which is the y-axis. Now, yeah, this is just in case if we're going to add some curl noise afterwards, and the curl noise is going to be, it's a spatial noise, so it has values on all axes. So if we add any, we can try this if you want. As you can see, if we disable the attribute wrangle, you see that the noise goes kind of everywhere, because it's in three directions. But when you multiply or just set the y value of the vector, velocity vector, to 0, you're going to have a really nice curl noise on the surface. Make a null here. Output the ground force. Out ground force. So yeah, and yeah, we're gonna also do the properties of our creature. So I'm going to copy this wrangle with the properties. I'm going to name it first, set properties, and set the properties here. And yeah, the The properties of our creature are going to be really specific because this is the result of testing and many iterations. I'm going to leave the dynamic friction 0.2 and the friction to 0.2 also, but we're also going to create a vector called dirArm, which is going to be well, first I'm going to add a point, and this point is going to be yeah, I'm going to just do some backslashes here. So my goal here is to define a vector that goes along of each of these arms. So the add will allow me to add a point in space, just one single point. We click the number of points, we'll put just one here, and it's going to add 1 point. A mouse will click on this add node, you'll see that there's one unconnected point. So if you press enter, you're going to see the position of this point in space. It's barely visible, but yeah, if you click this little button, display points, you'll see it. So I'm going to put it somewhere here. This is going to be a good point for our vector that we're going to create. So instead of set properties, I'm going to create this dirArm vector, which is going to be the position vector that subtracts the point attribute from the second input, from the point 0. And well, let's display this vector, dirArm. It displays by default as a color, but we go here and make a marker, vector trail. Yeah, so let's say red here. And as you can see, it's not bad. We'll have to modify just the so each point will have a vector pointing towards this point. So yeah, this is a vector that is going to control the direction of the compression of these arms. So the arms are going to pull in this direction, they're going to compress into this direction. So yeah, now we have a dirArm attribute, and I'm going to just set the y-axis component to 0 by using the same expression we used for the ground. With dirArm, we set it to 0, and the component is 1 because it's the y-axis. So yeah, now it's set comp, I forgot. Yeah. So now you have a vector that doesn't have a y component. It's set to 0. So this is done. Now we're gonna define a ramp, which is going to be a ramp based on the bounding box, the z bounding box of our object, our creature. So I'll hide this attribute, the dirArm attribute, and then I'm gonna show you the ramp. Let's make a temporary attribute, the CD color attribute, based on the z-axis. So yeah, this is the ramp that is going to define our density and stretch stiffness in the future for Vellum. So the goal here is to make a ramp which is going to be kind of centered here. What I want to do is tell Vellum that it's more dense and heavy here in the middle because it's the bulk of the body, and it's less heavy on the arms and the tail. So the density and the stretch stiffness. So it's going to be kind of heavier, harder to deform the middle than the arms. The arms are going to be much more flexible. So I'm going to define this gradient. This key is going to be like 0 with the value of 0, 1, because I don't want to really kill all the values from here. I still want to have some values right here. So this is going to be 0, 0, 5, and these keys are like 31. This is going to be like 41. This is going to be like 57, and this one like 65. So yeah, and yeah, we're gonna still have a value of 0, 0, 5 here because I don't want to kill any values right here. Yeah, so this is going to be the RAM that defines the density and the stretch stiffness, but we have to assign this to the density attribute and the stretch stiffness. So we're going to fit this RAM between 0 and 1 and tell them like fit this ramp in between two values, which are going to be max density multiplier, dense mult, and min dense mode. Min dense mode. Yep. Yeah, something like this. And I'm gonna copy this. You'll see how it connects later on in the setup. Stretch stiffness. Yeah, stretch stiffness. Yeah, so that's it. And we're going to define some values for the min density mode, max density mode. Gonna like change the order, like the the placement of these sliders. So the min density is gonna be 0.35, and the max density is gonna be 1. I'm gonna deactivate our CD. And now what we're going to do is copy our blinking attributes, this geometry. So with an attribute transfer, we're going to copy our attributes from above, and the attributes are going to come from the attribute copy here before the time shift. So yeah, the attributes that we're going to copy is CD and CDR. As you remember, we had the CD and CDR that control our movement, and as you can see, the scrubbing of the timeline is really fast because it's all optimized for quick playback. It's because we used only VEX code above, and we didn't use any loops that break up the geometry. So I found that this way is the best for transferring live attributes to a tetrahedral mesh. Yeah, so, and also we're gonna, let's attribute blur this. One of my favorite nodes is attribute blur because you can basically blur any attributes. So I'm gonna blur the CD, and as you can see, it's gonna blur the color at the edges, which is great. I'll leave it on one iteration, or maybe two, let's say two iterations. And yeah, so, and we're gonna place a master transform. The master transform is going to be the one that will be manipulating the whole geometry above the ground. So let's template this ground force. You see that it's penetrating the ground, and I want to move this above the ground because the creature is going to fall onto the ground and then start walking. So this is the full prep setup for the simulation. I'll press C here and just change the color of this network box. This is going to be our ground force. And yeah, what we're going to do in the next lesson is create a force that will be moving the arms of our Joey creature, faceless Joey, and we're going to do it in SOPs first, and then we're going to move it to the DOPS, because to avoid resimulating and testing and doing stuff that take time, I'm going to just make sure that we have a working force outside the DOPS and we don't have anything to simulate, and then we're going to put it into the DOPS networks, into the Vellum DOP, and this is where it's going to work its magic. So for now, we're done with this chapter, so see you in the next one.